Hello, my dear students. So today's class is about chelators, growth factors, and buffers, which we are used in the fermentation media. In the previous class, what we discussed it is about the media formulation and the carbon requirement, then nitrogen requirement, and then minerals that we discussed in the previous class. Okay, so today's class is about chelators, growth factors, and buffers. Myself, Dr. Shibu from the Department of Biotechnology. Safi Institute of Advanced Study. So we'll move to the topic. First is this chelators. You maybe heard about this word chelators. So this chelators, which is adding to the media to prevent the precipitate. Okay. So many media cannot be prepared or autoclaved without the formulation of a visible precipitate of insoluble metal phosphate. There is a problem, major problem during the autoclave of industrial media, that is a precipitate. Okay, there is a formation of the metal ions or the precipitate which will leads to disturbing the media. Okay, so in order to prevent this precipitate, we are using this chelators, as we already know about this chelators. During the isolation of DNA, we'll use EDTA as a chelating agent to prevent to protect the DNA from the DNase activity, that we already know that. Okay, similarly here also we'll use certain chelators. Okay, that they mention count 1984, count et al 1984 demonstrated that when a medium of Mandels and Weber was autoclaved, a white precipitate of metal ion is formed, which is containing all ions and most of the calcium, manganese, and zinc metals. Okay, so when the metal is combined with the other chemical to form a precipitate, they found out in the Mandels and Weber when it is autoclaved. The problem of insoluble metal phosphate may be eliminated by incorporating the lower concentration of chelating agents such as EDTA, ethylene diamine tetraacetic acid, then citric acid, polyphosphate, etc. can be added as a chelating agent to prevent the precipitate, as I already said. These chelating agents preferentially form complex with the metal ion in a medium. The metal ions that may gradually utilized by the microorganism. The chelating agent that we used in this media formulation, it will make a complex with the metal ions, and it will in Kb this metal ion complex can be gradually utilized by the microorganism, so it won't disturb the fermentation media and precipitate. Then Gaunt in 1984 they mentioned that they can show the elimination of precipitate. They can found the elimination of precipitate from Mandels and Weber medium when they are adding this EDTA at 25 milligram per decimeter cube. When they are adding EDTA at 25 milligram per decimeter cube, they'll found out there is no precipitate formation. They can eliminate the precipitate formation in the Mandels and Weber media. Okay, so then it is important to check the chelating agent does not cause any inhibition of microbial growth. So we should be care should be taken when we are adding this chelating agent. Maybe this chelating agent should not inhibit the growth of microorganism which was cultured in the fermentation media. In many media, particularly those commonly used in larger scale process, there may not be a need of adding a chelating agent as a complex ingredient, and such as yeast extract or proteose peptone will complex with metal ion and ensure the gradual release of them during growth. Okay, so in many of the fermentation media, when we are going for a large scale, there should not be any use of adding chelating agent separately. We don't want to add any chelating agent as a separate part. It's a complex mixture which is having yeast extract or this peptone will complex with the metal ion, and it may support the gradual release during the growth. Okay, so that is about the chelators. Next is growth factor, which will support the growth of organism during the fermentation. So all the microorganism cannot able to synthesize the growth factor, which is essential for their growth. In such type, we need to add that particular growth factor into the media, so that it will help the microorganism to grow. The growth factor most commonly required are vitamins, but there may also be need for specific amino acid, fatty acid, or sterols. Okay, So the growth factor in the growth factor in the form of vitamins or amino acid or fatty acid or sterols, either one, it may be required for the organism to grow. Many of the natural carbon and nitrogen source used in the media formulation contain all or some of the required growth factors. Okay, so during the media preparation, we are adding carbon, nitrogen, and other mineral source. We are use it for the media formulation. That will also support, and that also having certain growth factor which will support the growth of microorganism. We don't want to add any growth factor separately to the media. If it is needed, if any growth factor is needed, we should have to know that we need to remember that if only one vitamin is required, it may be occasionally more economical to add the pure vitamin instead of using a larger bulk of cheaper multiple source of vitamin. So we should have to remember that if any one vitamin is required for the fermentation medium or for the microbial cells, we need to add the pure form of vitamin to the media instead of adding a larger bulk or the cheaper multiple sources, which will disturb the downstream processing. Okay, that we need to remember. Then calcium pantothenate has been used in the media formulation for the preparation of vinegar production. Or the preparation of vinegar production, they will use calcium pantothenate as a growth factor. In a process used for the production of glutamic acid, limited concentration of biotin has been used. Okay, in limited concentration of biotin will support the production of glutamic acid. Some of the strain which also require time, it depends. Okay, it depends of the microbial cells, the growth factors may be vary, that should be added to the media. Okay, so that is about the growth factors. Now the final one, it is about buffers. Okay, buffers, we know that all the media, it's required buffer, proper buffering capability should be needed. If you are maintaining the buffer at a proper pH, then only your fermentation media should be suited for the growth of microorganisms. Okay, so the control of pH may be extremely important if optimal productivity is to be achieved. That we know that when we want to go for an optimal productivity, we need to control the pH. Okay, compound may be added to the medium to serve specifically as a buffer or may also used as a nutrient source. We can use any of the material that we add as a nutrient source, that also will support the pH. Okay, so many media are buffered about pH 7 by the incorporation of calcium carbonate, common chalk. If the pH decreases, the carbonate is decomposed. Okay, now all many of the media we set it for the pH 7 by adding or incorporating the calcium carbonate. When the pH is decreased during the fermentation process, the carbonate is decomposed. Okay, obviously this phosphate in the media which is play a important role in buffering. The phosphate in the media which play a major, not only it is act as a nutrient for the microbial cells to grow, it also act as a buffering agent to maintain the pH. However, it require high pH concentration, it is needed for many secondary metabolite productions. Okay, so the concentration of phosphate in the media should be high. It is act as a nutrient source as well as it act as an agent for a pH. Okay, so we need to add the phosphate concentration little bit higher. The balanced use of carbon and nitrogen source will also form a basics of pH control, as buffering capacity can be provided by the protein, peptides and amino acids such as in a constip liquor. Okay, so the balanced use of carbon and nitrogen source is also suitable for maintaining a proper pH control. We don't want to add any extra pH material into the pH, adjusting the pH of the solution. So the component which we are used as a nutrient source or a minerals or a vitamins for the media, that will support or that will maintain the pH. Okay, so that's what it is mentioned. And if the pH it is not set for a proper way, we need to add an external agent. The pH may also be controlled externally by the addition of ammonia or sodium hydroxide or sulfuric acid to maintain the proper pH. Okay, so that is about the buffer. Hope you understand. So today we mentioned about chelators, growth factors and buffers which will support the growth of microorganism during the fermentation process. Okay, so the remaining we'll see in the next class. Any doubt, you can contact me. That's all for today. Thank you all.